Alright, so you're having trouble with Introduction to Combinatorics, the handout that I gave out recently in class. Today we're going to work through just a couple problems in order to help you kind of wrap your head around these ideas so that you can do them a little bit more confidently while you're at home. One little typo that I want to kind of fix up, if I remember correctly, there's supposed to be an 8 here and a 6 here. This is a column just so that we're really clear about what we're looking at here. I'm going to work through number 3 and 4 from this here, just as so that you have a frame of reference into what it is you're doing. What we're going to talk about first is kind of the general notion of the procedure. So the first thing we're going to do is we're going to look at it's either a combination or a permutation. And the way that we figure this out is we think, does order matter? Well, there's obviously one of two choices. Yes, the order matters, then it's a permutation. And if the order doesn't matter, then it's a combination. Okay? Now when I say order, what do I mean by order? What I mean by order is the order in which I make these selections. Okay? The next thing we would talk about here is n versus r. Well, n is the number of objects, and these objects can be people, these objects can be toppings, these objects can be whatever. And r is the number of selections. Alright, so let's start the first part here with number 3. Identifying the number of objects versus the number of selections is pretty clear. So what I like to do is draw a little picture every time. So I've got I'm choosing 4 ice cream toppings from a bar having 12 choices. So I'm going to go ahead 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so that's the first part of the picture I could draw. So that means we're looking at 12 objects. So right out of the gate, I know that a 12 pops into this box here. Okay? And I'm making 4 choices. So we'll say this one, this one, this one, and this one. And just to make life a little bit easier for us, let's number the choices. Let's say we chose this one first, second, third, and fourth. Now the question becomes, does order matter? Well, let's say if I reverse these, so instead I did 1, 2, 3, 4. Have I changed the ice cream? I think it's pretty clear here that we haven't. If there's 4 toppings and they're the same toppings, it doesn't matter what order we put them in, they're all still atop the ice cream. So since the order does not matter, we're looking at a combination. Sorry, I almost messed that one up. Alright. Now, something I forgot to do. We obviously made 4 selections, so the 4 goes in here. And we're done. We have everything filled out that we need for this problem. Alright, now, the next set of problems here, I'm told it's a permutation, so I'm going to go ahead and do this one in red so that you see what I'm doing here. We're told it's a permutation, okay? So here's what we know. We know that the order matters. Okay, we know that. And I'm starting with 7. Starting with 7 objects. And choosing 4. Alright, so I'm starting with 7 objects and choosing 4. So let's say 7 objects. A really good example of a permutation is a word. So let's say I list out the letters A, B, C, D, E, F, and G. Okay, so if I have these 7 letters, I need to choose 4 of them. Obviously, if I choose B and then, so if I choose B and then A and then D and then E, okay, then I've made the word BADE, B-A-D-E. And if I choose, say, A, holy crap, A, D, E, B, I've got ADEB, not a word. So it does matter the order in which we choose these in. So what we're talking about here is making words. So how many, because we're talking about how many when we're talking about combinations, the number of ways a thing can happen, how many 4-letter words and let's put these in quotations because they don't necessarily have to be words in the English language, can be made with these letters. And that's the type of thing I'm asking you to do here. I'm asking you to write a problem, whereas in the other examples you were asked to evaluate and find little bits and pieces of them. Okay, so that's an example of what we're talking about here with numbers 3 and 4. And once again, my job is not to do the worksheet. That's your job. I just want to get you started, help you break ground a little bit. All right, I'm going to do one from the second flurry of problems there at the bottom. What we have here is you have the notation, and what we have to do is come up with a situation, or we have to match it up with a situation that models that. Now, we can have multiple answers here, so we need to be prepared for that. So let's look at number 9. Number 9, we're looking at 6P4. Now the P, obviously what we're talking about here in this part is a permutation. And what a permutation means is the order matters. So here's what we know. We know 1, the order matters. Order of selections matters. Alright, so what I'm going to do is kind of go through and start figuring out which ones this fits. So the number of ways 4 students can be chosen to represent Byrd High School for the state mathletes competition. Well, the problem we rub up against here is we're not looking at a permutation because it doesn't matter what order I choose them in. Okay, so I know it's not going to be A. The number of ways 3 job openings can be filled with 5 applicants. Well, it doesn't matter who gets hired first or last, it just matters if you get hired. So it's not going to be this one. The number of 4-digit passwords containing only vowels. Okay, passwords. So that's huge. Obviously, if we had a password containing only vowels, let's just say we had 4 digits A, I, O, E. Well, if I type that in and the password was actually E, A, I, O, then that would totally not work. So I know that this could be it. The number of ways 3 cheerleading captains can be chosen from a group of 5 seniors. This is actually a lot like A. So for me, I'm saying, all right, this is not a permutation. And for here we have the number of 3-digit numbers where each digit has to be odd. Okay, well here we're talking about 3-digit numbers where they all have to be odd, so I could say like 135. Well, that is different from 531. So here we're looking at a permutation as well. So right out of the gate, I know I'm looking at either C or E. And really, I've kind of helped myself out a little bit as well, because now I'm looking at 9 and 11. I could answer both of these at once, kind of. All right, now, the next thing I know. Well, what we need to figure out now is what those other parts of the notation mean. So what does this little thing mean? What does this little 6 mean? Well, this is my n value, which means there are 6 objects. And this is my r value, so I'm making 4 selections. Alright, so here's we got the number of 4-digit passwords, so we'll kind of pop C over here. The number of 4-digit passwords containing only vowels. So we need to consider Y a vowel. So you make a list of the vowels: A, E, I, O, U, and Y. Alright, so it looks to me like we're going to be choosing 4 of these. Okay, we're going to be choosing 4 of these. So I could say A, I, O, and Y. So it looks to me like this is going to be the winner. So I have 6 as my n value. I'm choosing 4, and the order I choose them in matters. So this is a permutation. And then for E, the number of 3-digit numbers where the digit has to be odd. Well, what are my odd numbers? 1, 3, 5, 7, 9. And I've got those 3 positions to plop them in. Well, alright, I can, I have to remember that for these, I'm just going to end up choosing one of them. Now, one thing that I realize now I need to add to the worksheet, there can't be repeats. So I'll probably tack that up here. So, it looks to me like for this part, what I'm looking at is E would probably end up matching up with 11. And it looks to me like C would match up with 9. So that's probably the most efficient way that you're going to want to work through these. And really the thought is in kind of populating this list, like the A, E, I, O, U, and Y, and remembering what odd numbers are, 1, 3, 5, 7, 9. And this is really basic information. So this should be pretty obvious and apparent to you if you give this thought. And I know a lot of you guys are coming from really simple elementary algebra and geometry, where that might not necessarily be something you do a lot. I know geometry has gotten a lot tougher as of late, but I'm going to really encourage you guys to keep at it. All right. Thank you so much for watching. I hope that you guys can finish the rest of this homework without any problem. If you have any questions, obviously let us know, but I hope that this is enough to kind of get you going. Alright, thanks.